Hello learners, we will see a new principle which is Alembert's principle. It is written as D apostrophe Alembert's principle. Some we can say Alembert's principle or D Alembert's principle. It is a principle which is derived from Newton's second law. Newton's second law of motion. So Newton's second law of motion is F equal to ma or sigma F equal to ma. If there are a number of forces acting on a body or a system of forces are there, then sigma F is equal to ma. That is Newton's second law of motion. The statement of the Alembert's principle is, it states that if a system of forces is acting on a body which is in motion, then this system of forces will be in dynamic equilibrium with the inertia force. The statement: if a system of forces is acting on a body in motion, then this system of forces will be in dynamic equilibrium with the inertia force. You know what is inertia? You might have heard of inertia. What is inertia? This is resistance to change of state. That means if a body is in state, if we apply a force, it will not move immediately. That is due to inertia. Or if a body is already in motion, if we apply an opposite force to stop it, then the body will continue in its motion for some time. That is called as inertia. So it is a resistance to change of state of a body. Okay, so in this, the system of forces acting on a body which is in motion will be in dynamic equilibrium with the inertia force. So using D'Alembert's principle, we can convert a dynamics problem into a dynamic equilibrium problem. Let us see how we can convert this into a dynamic equilibrium problem. So from Newton's second law, we know sigma F equal to ma, where sigma F is the net force acting on the body, m is the mass of the body, and a is the resulting acceleration due to the net force. Okay, so this sigma F equal to ma can be written as sigma F plus minus ma equal to 0. And look at this equation. So this will be sigma F minus ma equal to 0. Okay, so this equation looks like a static equilibrium equation. Okay, this equation looks like a static equilibrium equation because sigma F equal to 0 or sigma F or F1 minus F2 plus F1 equal to 0. This equation is like a static equilibrium equation. Here, this term minus ma, this minus ma is called as inertia force. It's called inertia force. So it will always be opposite to that of the motion. It will always in the opposite direction of motion, inertia force. So minus ma is called as inertia force, minus ma. So that is D'Alembert's principle. So the statement of Alembert's principle is, if a system of forces is acting on a body in motion, then this system of forces will be in dynamic equilibrium with the inertia force. And in mathematical form, we can write it as sigma F minus ma equal to 0, where minus ma is the inertia force and sigma F is the net force acting on the body.